On behalf of the Czexpats in Science, I would like to warmly welcome you to the hashtag Czexpats online lecture series, with tonight's topic being, can carbon capture mitigate climate change? My name is Zana Herrera. Czexpats in Science is an NGO which takes pride in connecting a network of Czech researchers working abroad amongst themselves, as well as with the research institutions and scientists back in the Czech Republic. Further, we provide help to any researchers to navigate the Czech research environment and develop a career in the Czech Republic. Having catered originally to the many Czech scientists who live abroad permanently, but wanting to keep in touch with the Czech scientific bubble, Czexpats in Science created this series of lectures and panel discussions. With help of the hashtag Czexpats online series, we are not only connecting the Czech science expats throughout the year, but it also allows us to highlight important discoveries and interesting research being carried out by Czech researchers abroad. After the main presentation, which is planned for approximately 1 hour, there will be also time and space for unrecorded questions and open discussion. Finally, I would like to thank our sponsors, specifically the IOCB Tech Foundation, Diana Biotechnologies, ContiPro, Bacala Foundation, the Kellner Family Foundation, and the Charles University. Thanks goes also to all our friends and supporters without whom these lectures could not be organized. And last but not least, to all of you who have made time to join our lecture this evening. And now I would like to hand over the microphone to our moderator, Blanka Koles. Blanka, the stage is yours.
Thank you, Susanna, and a very warm welcome from me also. And I would like to introduce our speaker for the evening, who is Kim Senger. I'm particularly happy to hear him speak because he also happens to be my brother. After completing his secondary school in England, Kim first went to the university in New Zealand, starting in Auckland, and completing his degree in geology and geophysics at Dunedin's University of Otago. From the far south of the world, he went to the opposite tip to pursue a master's at the Arctic University of Tromsø, where he focused on gas hydrates. After a 2.5-year stint that he spent in industry, working as an exploration geophysicist for Biogas in Norway, he went back to study for his PhD jointly at the University of Bergen and the University of Svalbard, where he is now in Longyearbyen, focusing on a CO2 storage project in the Spitsbergen archipelago. Following a couple of years as a senior geologist with the company EMGS, Kim returned to UNIS as an associate professor in 2015 and has been there ever since, focusing on both research and teaching. But I think his career in the North hasn't been all about research and teaching, as he has done several long expeditions during his time in the Arctic. In the spring of 2007, he and 4 of his friends set off as the Frozen 5 expedition, aiming to cross the Spitsbergen archipelago from the north to the south, which they managed to succeed in doing, taking 77 days to cover over 1,000 kilometers of Arctic wilderness in that time. And later on, during the first half of 2010, whilst contemplating his next move before his PhD, Kim took another long trip, this time crossing all of Norway from south to north on skis and on foot. Søndagsturen, he called it, a long series of Sunday walks, such as those traditional undertaken by many Norwegians on weekends. No rush, nowhere to be at a particular time. He was alone or joined by friends and family for parts of the route, and he took about 6 months to complete the 3,000 kilometer route. So with that, I will hand you over to Kim and let him tell you about whether carbon capture might be useful in helping us mitigate climate change, and tell us something about working in Svalbard.
Thanks a lot, my sister. And thanks a lot for this invitation to share some insights from actually living and working in this space, this office. This is the University Center. It's not Starship Enterprise, but it is the biggest building on Svalbard. There's another important building on here for the Czech community, the Czech Arctic Research Station, located over here. And of course, as you always have to have in a presentation about Svalbard, there is a polar bear, but it's actually hidden here in the museum. So you have to come here in person to visit. A little summary about myself. So I was both in the south and in the north. I cannot really do anything, but I cannot do anything properly, but I can do many things quite well. So my research interest is kind of spanning both the academic side, but also the industry side. It relates to unconventional petroleum systems like gas hydrates and shale gas exploration. It relates to how the Arctic Ocean north of Svalbard opened up in the early Cretaceous 125 million years ago and how this influenced the global climate. But it also revolves around these topics of digital geology, data integration, and CO2 storage. So these are the three ones which I highlighted here to kind of expand on in this talk. It's easy to do research and teach Svalbard geology because it's really a playground up here. We have everything and anything, and the only reason we have a university here or even a settlement is because of geology. This is a geological map of Svalbard. I'm not going to go into the detail of the different units, but important thing here is in the yellow, it's a big sedimentary basin, and at the edges of this basin are the only main settlements you have on Svalbard. We'll come back to living on Svalbard at the end of the talk and the discussions. But here's Longyearbyen, there's Barentsburg, there's a defunct mine here at Svea, and there's also now research station Ny-Ålesund, but all these settlements are there because of the geology. These lines here, they are fault lines, so there's actually a lot of different compression when continents collide. Then there's also when continents go apart. We have evidence of that on Svalbard, so compression, extension, strike slip. A lot of different type of lithologies as well. And they have very much been deposited throughout geologic time with only a few gaps in the stratigraphic record. One is in the Upper Cretaceous and one is now in the Neogene. But overall, this tells us a story of Svalbard drifting north and of the global climate change occurring at geologic scales. What we don't know about, not even Norwegians know that much about it, is that Norwegian oil exploration started onshore Svalbard. These red boreholes here, these red dots, they are exploration boreholes. Some of them, I'll move this image so you see this image down here. This is 1965 when American company called Caltex brought in 900 tons of equipment to drill the deepest borehole ever to be drilled on Svalbard, 3.3 kilometers. They never found anything commercial, but it provides us very important data to collaborate the outcrops with the subsurface. This is a picture of also another exciting borehole drilled a bit later, drilled in 2008-9. That's a CO2 lab I'm going to talk about, and that's located right here, just at the outside of the town. So it's a playground for us geologists, but it's also a playground for climate scientists and people actually studying climate change and how it affects us as people. One of the reasons of Svalbard being a hotspot for that is that you have this polar amplification. So if you warm up the climate, if you warm up the planet by a few degrees, the biggest change by far is happening up in the high latitudes. So this is why Svalbard and most of Siberia is experiencing the biggest temperature change in the world today. That is one-to-one related to carbon dioxide emissions, as you see down here. And then the theme of my topic then of the talk today is, well, can we as humans, as geoscientists, as engineers do something about it? And it comes, okay, well, maybe we can, instead of emitting the CO2 straight in the atmosphere, we can store it in the subsurface. And let's be pragmatic about it. This is not all very, there is quite some heated debate, maybe not so much now as there used to be 10, 15 years ago, but you can kind of think about it, well, we are emitting this CO2, what we're going to just do it, put it under the carpet. That's how you clean up a room, right? And I had to throw in this slide as well, because nowadays there's a lot of focus from all sorts of both science, industry, society on hydrogen. And, you know, hydrogen being one of the key fuels for the future, especially if you can generate it from renewable sources only, because this can be used in many of the different sectors where we currently really struggle to lower the CO2 emissions. Can be both in power generation and heating, various transport mechanisms, and of course the industry. We are not quite there yet. partly because we don't have access to a lot of hydrogen, and then there's the different colors of hydrogen and whatnot, and of course the green hydrogen which you generate from electrolysis with renewable electricity, that's just a fraction. But when you look at this blue hydrogen, where you essentially use the steam methane conversions or gasification, that's more or less the same, but if you that process produces quite a lot of CO2, so then the hydrogen itself is not really so useful for society. It's not so green anymore. But if you can capture a large proportion of that, maybe 85-95% with carbon capture, then you have blue hydrogen and you can really start reducing the emissions across the value chains here. But let's take a step back. What is CCS? What does it stand for? The first C is for CO2 capture. This can be some power plants, industrial cement factories. And then it's transported, can be pipeline, truck or ship to some storage facility where it's injected deep underground. And I was working in oil business. That's where we essentially try to take some fluids out of the same reservoirs up and produce and sell them and fuel the energy needs of the world. But here now we're just doing the opposite thing. We're just going to inject the CO2 into that. There is also this U sometimes referred to in CCUS. So again, source capture, transportation and storage. But CO2 is also a quite important product which is used as, for example, to enhance oil recovery. It's also quite heavily used in beer making. It's used in greenhouses in Netherlands. So we should not forget that CO2 also has a usage. Again, this is kind of the typical cartoon. You see it. It's a American businessman who was made rich in oil business, and now they can get rich again using the same method, but for CO2 storage. On the capture, this is for the engineers. I'm certainly not an expert on that, but there are a few different methods called post-combustion, pre-combustion, or oxy-combustion. Some cartoons showing it. This is an actual facility at the fuel power plant in, I think it's in Illinois, the US, onshore US. So this is how big the facility is compared to the coal-fueled power plant here. It is quite energy intensive and it takes some space, but it's technically mature and it's usable technology, and of course the costs are going down as everything else. Another, I will show some example from offshore North Sea, and there is not industrial source like a chimney with a lot of CO2 going into the air. The source there is actually natural gas field, which is naturally rich in CO2. And this gas actually, it's North Sea, Norwegian North Sea. I think some of it also come to Czech Republic. And to be able to send it down in the pipeline, the CO2 content must be lower than 3%, but naturally it's about 10. So since about 1996, it's been separated on a platform and re-injected in this saline aquifer. So that's also like natural rich CO2 fuel is also a source. And then, again, I'll move myself a bit around, keep moving, is this technology which a Swiss company called Climeworks developed and tested successfully in many places in the world, including a pilot study in Iceland with injection. That's direct air capture, that you actually take CO2 straight from the air anywhere. You don't really need a point source. And this is maybe actually becoming quite important in the future. I'll come back to the different units of the geology. What do you need for that? So back in Svalbard, and here's a map. Here's our Central Europe. Here's Svalbard. Say we are within walking distance to the North Pole. A friend of mine went from North Pole to Longyearbyen on skis and kayak a few years ago. We also had some people rowing out here. So we are kind of accessible. And as you see, this is the town. That was where the university is. That's the airport if you ever pass by to visit. These are all the coal mines in the area. This is the only active one. And about 25,000 tons of coal from this mine 7 is burned at this power plant. Another 2/3 are exported for steel manufacture. And this generates some CO2 emissions. And our idea was, okay, can we actually store some of that right here in Advendal in this main valley? So we drilled a bunch of wells. We have done most of the work actually during my PhD and a few years after that, 2007 to 2015. Now we follow up. Actually, a PhD student just finished yesterday on the Caprock. But the politics has changed. And I mean, the politics is more or less that this guy here, the power plant, is going to be shut down in a few months. In the meantime, we'll be running on diesel aggregates and whatnot. And there is no investment in the capture facility. So that's why we never injected any CO2 out here yet. Always good to keep the numbers in the head. How much, what are we talking if I'm telling you 60,000 tons of CO2? Is it a big thing? It's a small thing? Well, it's not that small, but it's not that big either. I mean, 1 million tons of CO2 is injected at the Sleipner facility offshore. That's the global area. And if you take a flight up here from Svalbard from Oslo, you'll probably be using about half a ton emissions. Just some comparisons. Per person, of course, we are few people here, and we are the world's best. Maybe not the best category to win, but it's roughly 70 tons of person per year. That's about 2/3 more than the country with the highest per capita emission. That's Qatar, and it's roughly 10 times more than Norway. The good thing about that is that actually a lot of these emissions come from a single point source, these coal-fueled power plants. And again, this is the same size sort of plot as here, looking at carbon emissions per capita, just in different categories. And look at, this is the 20 limit is here. We are on kind of the scale right here. Maybe you've seen it in the media. Actually, I have no idea what's going on in Czech with CCS, but if in the, for example, the IPCC report, that's from one of the figures there, the road to net zero, where idea is that by 2050, the global energy emissions in million tons of CO2, that's the past, and that's the kind of future trends, they should actually get down to zero by 2050. And there's a lot of things you have to do. You have to switch fuels, you have to electrify transport, but you also have to think about carbon capture through this direct capture, but also through CCUS in both the power generation sector and in the industry like cement and whatnot. So right now it's minimal. Right now this is what's the operating capacity. This is where we have to be able to reach this target. So there are quite some advanced development platforms, but there is still a big gap to reach it, and we have to be aware of that. This is not a small thing which can be done overnight. This is something to build up over time. Again, bring some numbers onto the table. That's the local emissions here. In Germany, there was an injection in place near Potsdam, Ketzin. They injected roughly the same as we have per year in total. And then now you're talking about roughly 1 million tons of CO2 emissions per year in the North Sea and some of the facilities there. Mostly Norway, but also in Denmark, which started recently. So what do you need as a geologist or somebody going to build up a CCS facility? You need a reservoir, usually sandstone. Sandstones are good, porous, permeable. On top of that reservoir, you need to have a seal. Often it's shale. It can also be evaporites or salts, but shales are the typical ones. And then you need to be at okay pressure temperature conditions. So you need to be deep enough, which again makes it safer, but it also gives you a CO2 density where the CO2 will be in supercritical or liquid phase and will not take up so much space. So if you look at this figure, it can be, these deep saline aquifers are the best because they have a lot of space, but often we don't know so much about the geology. it can be depleted oil and gas fields. Which in this case is this one. So there was already some oil and gas was produced. They are good because you know the geology, but the problem is you have so many boreholes and they are representing potential leak paths for the CO2. You can also store CO2 in unconventional units like basalts, where the advantage is that the CO2 will form minerals and be much more permanently stored as well. In Norway, there's quite some development, probably one of the leading countries in the world, which deals with CCS, and that's driven partly by politics, but also by money. So since 91, the offshore area here has been under a CO2 tax. It used to be, it was used to be, but now it's 70 euros. So actually, for the operators of this Sleipner gas field, it turns out to be cheaper to re-inject the CO2, separate on the platform, re-inject it, than to let it into the atmosphere. There's also a storage facility up closer to Svalbard, here at Snow White. And there's plan here, both of these are from natural gas in the reservoirs, but there's now plan to inject in this Aurora site CO2, which is actually sourced from point sources around Oslo, transported by ship out there. So this first injection here at Sleipner to the Utsira formation was also fantastic because there was a lot of monitoring done to really gain knowledge about what kind of methods can be used to see what's happening with the CO2. So it's 1 million tons a year. In total, it's over 20 million tons. It's injected here into the base of the Utsira formation, and then it sort of climbs up, and it's sort of this is the kind of perspective. So this is the injector well, and it comes up, and then it goes in the permeable layers. It looks almost like a little Christmas tree upside down. And these data are both profiles and map view of the seismic data collected at different time intervals. So you can actually, with the technology we have from the oil business, we can really monitor where the gas is moving. And the new kind of project, where also Peter, who just submitted his PhD, was working partly on, is this kind of moon landing. It's not a moon landing project, but very important project for Norway to demonstrate that you can have industrial CO2 sources. It's a waste to energy plant in Oslo and a cement factory close to Oslo, transported by ship to a terminal actually onshore, and then pump it down through pipelines on the seabed, and then down into permanent storage at 2.5 kilometers depth. This is what the geology looks like. Originally, the plan was a bit higher up, but actually it's below one of these biggest gas fields in Norway. Actually, again, lots of gas from Troll going to check, and this well was drilled last year, and injection is planned for next year. You look a bit about the media. There is a lot of activity. You can, as a company, you can apply for offshore licenses right now. There's these kind of maps where there is a lot of storage hub for CO2, not just from Norway, which is not really industrial nation, but also from Netherlands, from UK, from Germany. There's a plan to build a pipeline from northern Germany to Norway to bring the CO2 up there, and various different projects. The Danish have already started this. They have, in March this year, they started injecting CO2, project called Greensand. The CO2 there, it's also quite interesting because the CO2 which is injected in the Danish part of the North Sea comes from Belgium. So again, it's transported cross-border. And as you see, even von der Leyen here, she's at the opening ceremony saying how big moment this was for the green energy transition. I originally gave this talk in Germany, and I had to include something about Germany. And of course, Germany demonstrates the problem of CO2 legislation and CO2 opposition, storage opposition. So this was the site of the Ketzin pilot project, briefly mentioned. It's just west of Berlin. the problem is in Germany there are so many oppositions for people to have injections in their sort of backyard. Even the CO2 is not really such a dangerous gas as, for example, methane, and this is just an illustration of a map of all the natural gas storage sites in Germany. So that's methane, and there's actually quite a lot of it in all the different parts of Germany. But I think you can also see that the difference in Norway, you are storing large quantities offshore where nobody cares. If you do it in onshore, it gets a bit more complicated. So we move back to little Svalbard, a little bit different perspective, not the usual view, but now we're looking Svalbard first and then Scandinavia afterwards. So we don't have any CO2 tax up here. We have no tax really. And it's of course quite limited power plant, but it is the only one in Norway. There's also, the Russians also have a coal-fueled power plant. But what we have, what Norway mainland doesn't have, that are these sedimentary rocks. And that's what's really been driving this project, which was actually my PhD supervisor, Professor Alvar Bråten, and then director of UNIS, Gunnar Sand, had a chat together in 2006 and developed actually a vision of having a CO2 neutral society here in Longyearbyen. That was in 2006. And already a few years later, they were drilling these boreholes. This is on the road. That's the power plant again. That's the airport. So on the way from the airport, they were drilling a couple of wells, and then a few more, and then a few more, and then a bunch of injection tests with water. The budget of this operational phase was on the order of 10 million euro, split roughly half between public money and private money. It seems like it's expensive for a well, but this is cheap. This is sometimes oil rig will cost you that for a day, and now we're getting a 1 kilometer fully cored borehole for that. So that's cool. And the thing is that, since I came back from 2015, we finished the phase 2, and we're still using this data acquired to really develop and work up the data. And we are still ready to inject if there is a CO2 source in the future. So what have we done so far? That's what the site looks like. This is the Isdammen. It's an artificial lake we use for our drinking water. And here are our 6 wells. With also some pumps. The deepest well we have, it goes to 972 meters. I have a bunch of cores, always a lot of cores. So this is the core you get out of it. From different depths, so you actually can look at the rocks, you can analyze it different ways. Gets thinner and thinner down there. And then we have done some tests between the wells. So we injected high pressure water, partly from this drinking water supply, partly from the river. We have collected seismic data, again to have a baseline before injection. We have tested the seal with it's called leak-off tests when you try to generate some fractures. We are universities, so we have run a bunch of courses related to this. We still actually do. We have many PhD students, postdocs, master students, and we have also found quite some natural gas in different layers, which we studied and then wrote a few papers about it, and then we also plugged all the wells so that the CO2, the natural gas doesn't come up from the surface. In terms of geology, so these are the 2 boreholes here by towards the airport, and here are the 6 boreholes out here. Permafrost is a bit thicker in the inland part, and we are talking about, you call it Mesozoic in geologic terms, but Triassic to Cretaceous strata, so everything from 300 to 125 million years old. This part here from about 700 or 670 meters down, it's the reservoir, and then up there is the cap rock. When we look at the reservoir, we can also look at the porosity and permeability. Again, back to my point that you need a porous and permeable reservoir to take up this. So we have done that on the reservoir units here. We can plot up, there's a upper layer here, which is this thinner but better reservoir, that's this one. And then the lower part is a bit less good, but it's much thicker. So it's always a kind of balance. But so the reservoir, it's not perfect, but it's good enough. And what also helps the reservoir is that there's a lot of these fracture systems, fracture planes. It was my large part of my PhD was going around, looking at the core, measuring systematically all these different fractures and saying how do they, in terms of dip angle, how do they relate to the different units, and how do they contribute to the fluid flow. We did that on the basis of the drill course, but we also send them through example through a CT scanner. This is work done in Belgium, looking at the X-ray micro CT, this part and that part, and we actually can even start increasing the pressure to see how the fracture aperture changes. And then we can also sort of simulate CO2 flow through these kind of mini core plugs. The boreholes are fine. You can do this all year round. You can study them whenever. But what's the fun part is actually to go out into the field. And this is why we are geologists. It's not to sit in the office. It's to go out there. And that's how it looked like in summertime. A very nice reservoir, caprock, shale here. Some of my igneous intrusions, which are one of my research interests. And then we can kind of really relate to the outcrops to the drill sites together. Not sure why it's doing this. No? Hello? No? Okay, I have to keep pressing this button. So the outcrops, for example, tell us that, yes, we have quite some fault zones in here, which explains some of the challenges we had, because two of the boreholes, they don't seem to communicate even at short distances. So there must be some sort of structure in between, which based on the outcrops, we say, okay, it's related to one of these fault zones. And again, this is work following my PhD. That's more like this digital geology part, that now we are able to digitize using drone photographs, using photogrammetry, these 3D digital georeferenced models. We call them DOMs. You can call virtual outcrop models, digital outcrop models, but that's the input data, all these images. In this case, it's 79 photos merged together in photogrammetric software. And then you got this almost magically, you get this 3D textured georeferenced map of the overburden. In this case, it's a Festningen sandstone here with a nice thrust fault right here. And these vary from very small scale, from these even drill core samples to big mountain sites like this, and we can really use this all season long. And on the Svalbard platform, we can share this openly with everybody. So this is where we have all the models acquired, and we kind of make them available so people can download the models, they can download the input images. This is a project we did last autumn for the Longyearbyen Society. There's a ski slope being built, so we were scanning the mountainside with the photogrammetry. This is for the governor of Svalbard. We were making just flying around. I was on a master PhD course with some students with the governor's boat, and we're making just lots of images around the boat. Now we have a 3D model of the boat, which we can measure distances and whatnot. The same goes also for cabins and other type of infrastructure. And that's the fun part. And I mean, I heard something, I should put in a lot of photos and photos and photos. And I thought, okay, I'm not going to put in photos. I'm going to put in a couple of minute video, which is showing how we were going out on I think it was a 10-day Svalbard acquisition campaign in cooperation also with the Czech Arctic Station. So this was the UNIS team going around, staying on the wonderful sailboat Cleone, keep safe from polar bears. And idea there was really to systematically go out and acquire these digital outcrop models and also photogrammet, also 360 photospheres, these mountain sites. And then process it into the different models. That's how fieldwork in Svalbard looks like. There you go, there's Glione scale. Here's a drone and a selfie stick. Always good weather when we are out in Svalbard, of course. Never any issues with bad visibility. Then you can land with the Zodiac. Yes, there's a few icy parts. And that's kind of the highlight for us. And of course, the time when we can go out and collect this type of data more or less starts now. Still quite a lot of snow in the terrain. And it goes to maybe, if we are lucky, end of August or maybe middle of September, depends a little bit. But so we have a really short season, but if we are able to really harvest the information from these models and then work them up quantitatively, we can work all the year long as well. You see the strata here, the geology here is very much upplay, but it's very much turned, almost upside down. Rocks are not formed like this. Rocks are formed horizontally, but with these units here, they've been through a quite major mountain building collision, so they have been tilted upside down. Okay, let's get out of this video and then we go to some geophysics. So this is how when we are going around shooting seismic, so we collect also seismic ourselves. This is some of the data, connecting the two drill sites. You use actually in this case an explosive cord, and then you have a lot of receivers, and you're just sending pulses down into the subsurface and figuring out these different layers represent changes in density and velocity. So we have also that interpreted that you have some igneous intrusions and then the top reservoir, and we can really link that up. On a bit smaller scale, some of the work from Peter Bethlehem, who just can highlight again, he just finished his PhD. That's looking at the caprock shales. It's a digital outcrop model, but then we also collect some electrical resistivity tomography to see how these fault zones look like in behind the outcrop. Storage capacity wise, it actually goes back to a few years ago, my PhD, but there's no real changes. The way to calculate storage capacity is that you essentially use this formula. It's your area, your thickness, net to gross porosity, CO2 density, and then this storage recovery factor. And of course, you have a bunch of uncertainty in all of these parameters. So you don't just give one number, but you give a probability distribution, and then you plug it into the computer, and then it spits out also not just one final value, but some sort of range, which is here plotted as a mean and the upper and lower quartiles. So these are, and then we have to adopt a little bit different scenarios as well. Some relate to the geology, some more to the technical drilling parameters. But he can also match it to the CO2 requirement, because we can say we are never going to need more than 1.2 million tons of CO2 injected. That would be 20 years of CO2 emissions from the power plant. And this we can, under any kind of scenario, we can really, we really have that well covered. So that brings us to the conclusion of the CO2 pilot. We have both capacity and injectivity. The injectivity is done by the water injection tests, and then the capacity by these volumetric calculations. We have a lot of contribution from fractures. There is quite some barriers in between, whether it's igneous intrusions, whether it's fault zones. We have a heavily under pressured reservoir there. Actually, Tom Birchall did the whole PhD just to understand why it's under pressured, and that's related to us actually being on the way up since the last few million years after the glaciations. And during the glaciations, Svalbard has been going up and down, and it's still kind of readjusting to its present situation. We have a really good seal. We also have a lot of natural gas around, most of that is actually shale gas. So again, for us, it was a bit of a challenge because suddenly you have to deal with the whole health and safety issue of having quite some gas in the system. It had to be flared, controlled, and so on, and then plugging of the wells. But from a community point of view, it's actually not such a bad thought to maybe consider that as a potential local source, because natural gas is certainly less CO2 emitting than coal, or what we are running on now is actually diesel, which is produced somewhere else and imported here. And again, Svalbard is a playground in many ways, but also for us geologists. There's a few papers. What the site looks like now, there's no activity at the site. We also have the web page of Svalbard, and I just want to point out a few of the highlights. This was these digital outcrops which we collected, for example, from the boat, which on svalbard.no you can look at it. It's quite I think it's quite a nice tool because we don't just provide the models without having any context, but you can see them in terms of the geological maps, in terms of geophysical maps, and we don't develop any softwares. We just use what's out there, what's available, off-the-shelf solutions. Started actually before the COVID, but during the COVID, we of course were quite happy to have this tool to be able to even run some of the courses digitally around there. And then there is also a smaller, but a kind of sister project to these digital outcrop models. You can link to it from Svalbard, and that's via Svalbard, and it's a Brazilian PhD student we have here at UNIS, Rafael Horota, who uses the same tool. So you fly a drone, and at some point he just takes one image of a 360 photosphere. And these photospheres you can then, I mean, you don't even have to stitch it together because the drone does it itself, but you have different parts, and then you can start appreciating the geology of even the different times. And so it's not as quantitative as these digital outcrop models, but very useful tool. Is just an example of some of the models or photospheres available in the Petunia Bukta area. That's where Pyramiden, it's a Russian settlement, and also the Czech field station Nostok, which is located here. So this brings me to my last slide in terms of science, and I have to end on, of course, I talk about CO2, millions of tons which we have to emit. But remember, that's the governments, right? But we're all human beings too, so we have some choices we can make. Some of these choices are going to have less impact than others. And of course, there is one thing on the scale here, which is kind of elephant in the room, but of the scale, have one fewer child. I have 4, so I have kind of fulfilled all this quota for that, and I really have to do to have a good conscience. I have to inject at least 1 million tons of CO2 before I retire. And then I was also asked to just put in a little bit, maybe again to start a discussion, and maybe some people have more questions about the life on Svalbard and about the science in Svalbard. So I thought just to put up a few of the standard comments. People always say, there's more polar bears than people on Svalbard. It's not true. It's actually, we are more than the polar bears. It's true, you're not allowed to be born here. So we had to deal with the logistics of that when our 2 youngest were born. It's not because of politics. It's just the Longyearbyen hospital is not suitable for complications. And there are a few people who get born here by accident. You're not really allowed to be dying here. Of course, if you do, it happens. It happens more often than you think. A lot of accidents, rough nature. But you're certainly not going to be buried here, because then you would just come up with a permafrost, which is not a nice thing. Svalbard is fully Norwegian. It's also part of NATO, but we are not part of Schengen. The reason for that is because of the Svalbard Treaty from 100 years old, is not compatible with the free movement, because Svalbard Treaty is very much more open than the Schengen treaty in terms of which countries and citizens can come here. So actually when you come from Norway, you have to go through the international terminals. Oops. Fun fact, the Thai people are the most populous nations after the Norwegians. And I counted that we have 8 bars and 1 supermarket. The sun is, we are really, now we have midnight sun until September or end of August at least, but there's also quite a long dark season, so the sun will disappear in October and only comes back to the town on the 8th of March. So it's not really a place designed for humans. In terms of science, actually quite good place to do science. It's really nice to be based at Svalbard, not because we are such geniuses working here, but because it's very easy to make networks, because everybody, of course, is interested in Svalbard. And we have a really good track record also with operating safely and with minimal harm to environment. Actually, in 30 years of UNI's history, no major casualty to anybody, even though we have many thousands of years of days in the field as an institution each year. For education, of course, there's nothing better than UNIS up on Svalbard. And anywhere, I think you look at where our students end up, many of them end up in academia, much more than average, I think. But even those who end up somewhere else in industry, in public sector, they have a lot of skills to be able to, think outside the box and, deal with problems in the field when it's -20. You just have to, think a bit more than if you are just somewhere else. Our PhDs, I think they are the best paid in the world. They are paid exactly the same as in Norway, but here the taxes are lower and they get housing almost for free. But that's one part of the coin. The other part is that I think they are quite isolated too. You have to, and that's why I always push them out to spend some months at the bigger institutions, because we are relatively small. So it's important that they get a chance to spend at least half a year at another university. Yeah, and I mentioned it already a few times, but we have Czech Republic, we have our own research station here in Svalbard, and that's here. And with that, I like to thank you for your attention. And of course, if you have any questions or comments or discussions, then feel free.
Thank you, Kim. Thank you for the interesting lecture. I've never heard one before, so it's great. I'm going to first open the floor to questions. I've got some that I've noted down as well, so if anyone would like to start, feel free to just unmute yourself and ask, or write in the chat box. Otherwise, if no one else is ready to ask it, then I noted down here, how do countries without depleted oil and gas deposits do it with carbon storage? And I think you touched upon it a bit when you talked about Germany. Is the end basically that inland countries are going to be dealing with countries with seashore, with sea, and trying to get their CO2 into the sea? Or is it possible to get some CO2 down inland?
Yeah, I mean, there's a lot of sedimentary basins where you can store it also onshore. In northern Germany, the basin in Moravia, we have a lot of suitable rocks for this. So you can do this onshore too. The problem is the public opposition. So often there's demonstrations for, oh, we don't want to have CO2 storage here. And maybe it's not well explained. In Germany, it's also the regulations that is actually not allowed right now to do such a thing, but it may change. But the geology, whether it's in the sea or on the land, it doesn't matter. As long as you have sedimentary rocks, and you have them in many countries, you have some.
And there's a question here in the chat, which was also one of the questions that I noted down during the talk. How do you make sure that the CO2 stays underground?
You monitor it. You monitor with various techniques. I'll show you just one example with the seismic. You can also monitor it with observation wells, which are much closer, much more accurate, closer to the site. And of course, you have to inject in a place where you know there is also some sort of structural closure. So when you're looking for oil and gas in exploration, you look for these, maybe anticline traps or something on a fault zone. And then you find it and you produce it, and then it's easy. But when you're looking at the other way, you have to kind of find these traps first, and then you inject into that.
And if there's an earthquake, what can it do to? Does an earthquake? Could the earthquake cause for the CO2 to come up?
Earthquakes, and actually, I did feel an earthquake here in Svalbard, only place in the world I ever felt it. I lived some years in New Zealand. So there can be some earthquakes, but again, this is something which, if you have I think you have to look at it from a point at a little bit, some leakage. You have to minimize how much leakage is coming, of course, but it's not in the subsurface. Everything is always moving around, and you have to think about, okay, so what are the values? I mean, are you gonna say you want to store something for 100,000 years and have 100% success with no leakage, or are you saying, okay, it should be stored for 10,000 years, and I'm happy that I don't know, 0.01% is actually leaking? So these are the kind of risk models you can apply in there. But earthquakes can generate, they can reactivate some fault zones. It can be a little bit, I wouldn't say problematic, but you're never gonna have a huge CO2 emission, like everything you injected the last 20 years suddenly coming up in the surface at the same time. It's not gonna happen, and even if it did, it's not dangerous. The only thing that happens is that, well, you have not stored it then properly. But it's not like a health hazard like methane is. In that sense.
I've got a question here from Andrzej Czernoki, who's asking, do we understand why the Arctic is heating so much faster than the rest of the world?
Mm-hmm. Yeah, I think my colleagues understand it quite well, the meteorologists here do this and elsewhere.
Zawołam za chwilkę.
What we try to see, is polar amplification effect. It's of course partly also related to global circulation with the Gulf Stream and others. And what we in the deep time in these geologic intervals, when we go back 2 million, 50 million, 120, and so on, millions of years, we also want to see whether this kind of polar amplification we see today, whether that's also something which was there in the past. But we certainly know it's happening, and I'm pretty sure a lot of people know why it's happening, but I'm not so sure if I'm the one to answer the meteorology question.
Okay, and back to a question from Alishka, I think, in terms of the storage, is it worth the cost? What are the cost benefits around it?
That's a good question. How much do we want to? How much do we want for the planet to be not so warming? I guess that's everything has a cost, and then you have to rethink what are you, and is it a cost in terms of money? Is it in terms of, again, energy cost to run the process? Is it the cost in terms of all the infrastructure you need to make it happen on the scale which IPCC wants it to happen? It's yeah, it's a good question. I think it comes back to what is the cost of saving the planet.
I think a follow-up question to that a bit is, how demanding is it carbon storage in terms of used energy? And if you're using the energy from fossil fuels, is it going to go around in circles?
Yeah. So that's the point that, like, I think here in Svalbard, which is where I can comment, I am not 100% sure of the, energy intensity of all these different technologies on the capture side. Again, this is, you have to talk with an engineer to have the input on that. But here in Svalbard, where we were seriously considering to having a capture facility in 2009, 2010 at the CO2 at the coal-fueled power plant, the cost then would have been about 1 billion krona NOK. So this was about 10 times more cost than what we spent for about 8 years of subsurface work, including the drilling, injection tests and everything. So it would be an order of magnitude more for the capture facility in terms of money. And there were, at that time, again, this is more than 10 years ago, so I'm pretty sure technology has developed since then, but even back then, some of the challenges were that the power needed for this capture facility to work was more than the capacity of the power plant. But of course, this is a very specialized case where everything is, a small city with few thousand people. Somewhere can be different if you are in big industrial area. But here there was actually both the economic cost and the energy cost. But the last one I think was probably the most important, is that I think already back then they decided the coal fuel power plant will not be here for the next 2-3 decades to really warrant that kind of investment.
Sorry, I've muted myself. A follow-up question from Martinullah is, what do you think about the state of Svalbard as in now? They want to close the coal power plant, but they are not ready for it. They want to use diesel fuel, but during the winter they're going to have to warm it up. So how are they going to deal with it? Do you have any comments on that?
Yeah, I think it's a mess. I think it's a mess. It's a political process which started actually many years ago when the Norwegian Oil Fund said they will not invest in coal companies worldwide. And then, of course, the Norwegian state owning the coal company which built up Longyearbyen was seen by many as a little bit strange in that context. So there was actually closure of Svea mine, which would have been super profitable now. Completely new mine, again, cost 1 billion krona to build and then to clean up. Longyearbyen, the mine actually may keep going for a while because now it is actually profitable. But we will probably not use the coal-fueled power plant. The diesel, we already using it quite a lot. It's imported here. It was always actually on this picture. This is one of the one of the system of this heating part. We have also saying maybe this gas could be a good solution. We are looking at geothermal energy, again based mostly on the CO2 lab boreholes as well. So that could be another part. But I think many people have a lot of ideas, but in practice we are just, I think this imported diesel is just going to run for the next, I don't know, at least 10 years. I don't have much belief in it, to be honest. And we had a really big spike because it's still not sure who should pay for all these energy things. So now from January, the energy prices here in town, it's like 50% more than it was before.
Another question from about the life there. How is it with the Russians now? Does it mean that in Longyearbyen people still cooperate with them, or are they separated? The question is that I follow a lot of them from the past on Instagram, for example, and it looks like they are quite in anti-war opposition. But what about the company itself?
Yeah, so you see, this is a check station. This is Ruski Dom. So the Russians have these two towns, one Barentsburg, where it's about 350 people, both from Russia and Ukraine, working for the state-owned company to start the Google. And then Pyramiden, where it's maybe 8 people. It used to be much more. And there is not much regular well, I mean, the companies, for example, the tourism companies in Svalbard, part of Visit Svalbard, they actually threw this Russian company out after the war started. Took a bit longer time, but then they did it. And they also say that the member companies should not visit these Russian settlements and actually spend any money there, because that goes straight to the Russian state. University does the same. So we used to run field trips with base in Barentsburg, with base in Pyramiden for many, many years. This was not possible since last year. But of course, it's still there. So actually, we see a lot more, for example, Chinese tourists who are coming to these settlements. Some of them through Longyearbyen, some of them by boats. There's also Russian tourists coming by boats and so on. So it's not, but there is much less cooperation than there was before the war started. And many have, many families from either Russia, Ukraine, who were working in Barentsburg actually seek asylum in Longyearbyen, but many moved to Longyearbyen and are now living here or went on to mainland.
Okay, one more question. Hi Kim, nice to learn about your research. It was a very nice presentation. Thanks for it. I have to leave, so that's just Joseph saying goodbye. I would just like to ask about your career, if I'm gonna, unless anyone else has got questions in the chat, then I'd just like to put to you a question. You talked about switching during your research career from academia and industry and back again a couple of times. So I was just wondering, what was it that made you go into industry and what made you return to academia?
Good question. I think to go to industry, of course, it's the salary. You work less hours for more money. No, I'm just kidding. I think it's important to be able to see what people are, what the society needs. And I think if we just stay in academia, you don't see that. And we as academics, we need to also educate the students with skills which they will have use for in their career, whether it's in industry, in public administration, whether it's in academia. And I really like this. I was once hitchhiking. I was hitchhiking a lot in New Zealand, and once I had a ride with, I think it's a professor of economics, and he had this quite nice theory that ideally in a work, in a sort of life perspective, if you spend 1/3 of your life learning new things, and then you spend 1/3 of your life working with these things you have learned, and then you spend 1/3 of your life with kind of teaching others what you have learned when you learned yourself something, but also during the work. That's kind of a nice balance, but it doesn't have to be like in this order and in 30 years, whatnot. It can also be sort of a bit more fluid to go a bit sideways in the careers. And I think this is important. And I think also for some, I think just being able to have a few years experience, for example, before my PhD, make my PhD so much more worthwhile, because I had a lot more, I'm not sure if I was more mature or not, but I had much more different type of skill set to bring to the table. And I also, with even some of the brightest academics teaching ideas, well, just go for a few years in industry and see what it's about, and you can always come back. And to come to, of course, I don't know, sure if I would work anywhere else in academia except Svalbard, but here, of course, it's the geology and it's the freedom to really make and start stuff and work with fun people, work on cool stuff, and have a good time while doing it. So
I think on that positive note, unless there is another pressing question, I think I'm going to close the discussion. Is it okay if any of the audience have got any questions, they can contact you with them?
Yeah, sure. Email is
great. Thank you. In that case, I would just like to clap you from here and join for a virtual clap. And I'll just pass on to Susanna for the closing words.
Thank you very much, Blanca, and especially Kim. Thanks goes also, of course, to all of you for staying with us till the very end of this extremely enticing talk and discussion. Thank you very much. If you would bear with me, I would inform you about our further events and opportunities for you to get involved in. Should you be interested in being informed when another of these presentation series comes out, as well as about our other activities, please subscribe to our newsletter if you haven't done so already. We would also appreciate you filling in an evaluation questionnaire after this event, as this gives us a valuable feedback on what we can do better next time. You can also be directly involved in the activities of Czexpats in Science or join us as a volunteer if you are interested. It may be as little as joining our map of scientists or as much as taking the reins and organizing your own local meetups, such as the one that recently took place in Sweden and those plans, for example, in Switzerland and in London. Next week on Tuesday, the 20th of June, there will be a meeting of repats, expats, and scientifically inclined people in Davice in Prague, and Young PI Forum in Prague as well. And online the following week on 27th of June is the Young PI Forum. Sorry for mixing up the dates. We also organize regular workshop. The next one is on academic mobility after your PhD at the UCT in Prague on the 27th of June. More information can be found also on our website, czexpats.org. So the second summer meetup will take place on the 31st of August in Brno, and it will also be streamed online. So if you can't come to see us in the Czech Republic, please join us at least online. And we are looking forward to seeing at least some of you at the annual pre-Christmas conference in Prague on Friday, the 22nd of December. So please save the day and join us if you can. So thank all of you for your attention, and we look forward to seeing you the next time. Thank you very much and have a good rest of your evening.